children, today we are going to learn about the salts. There are three types of salts: acidic salts, basic salts and neutral salts. We have seen that salts are formed by the reaction between acids and bases. This reaction is called a neutralization reaction. Resulting salts are not always neutral. Neutral salt is formed by neutralization of a strong acid by a strong base. The aqueous solution of a neutral salt has pH equal to 7. Acidic salt is formed by neutralization chemical reaction between a strong acid and a weak base. The pH of aqueous solution of an acidic salt is less than 7. Basic salt is formed by a neutralization chemical reaction between a weak acid and a strong base. The pH of aqueous solution of such a basic salt is greater than 7. Now let's begin the water of crystallization. Try this. Take some crystals of blue vitriol in 2 test tubes. Add some water in 1 test tube and shake it. What did you see? What is the color of solution formed? Heat the other test tube on low flame of a burner. What did you see? What change did occur in the color of blue vitriol? What did you see in the upper part of the test tube? So dear children, when the second test tube cools down, add some water in it and shake it. What is the color of resulting solution? What inference can be drawn from these observations? Yeah, I know that you are very eager to listen the answer. It's a very interesting experiment. On heating, the crystalline structure of blue vitriol broken down to form a colorless powder and water will come out. This water was part of the crystal structure of blue vitriol. It is called water of crystallization. On adding water to the white powder, a solution was formed which had the same color as the solution in the first test tube. From this, we come to know that no chemical change has occurred in the crystals of blue vitriol due to heating. Chemical formula of blue vitriol is CuSO4 5H2O. In this, 5H2O is nothing but the water of crystallization. Chemical formula of ferrous sulfate, that is FeSO4 7H2O. In this ferrous sulfate, 7H2O is the water of crystallization. Washing soda, chemical formula Na2CO3 10H2O. In this, 10H2O is called the water of crystallization. And the chemical formula of alum, K2SO4 Al2SO4 3 24H2O. This 24H2O is nothing but the water of crystallization. Without the water of crystallization, there is no formation of crystal structure in any substances. The water of crystallization helps to form the crystal structure. If the water of crystallization is increased or even decreased, there is no formation of crystal structures. Hello dear children, today we are going to learn about the ionic compounds and electrical conductivity. Try this. Prepare a solution of 1 gram sodium chloride. How will you prepare? So it's very simple. Take 1 gram sodium chloride and dissolve it in 50 ml water. you will get the aqueous solution of sodium chloride. After preparation, take two electrical wires. Connect one wire to the positive terminal of 6-volt battery while connecting the other wire to the negative terminal of the battery. Include one switch, one holder with an electric bulb. Remove the insulating cladding from 3 cm portion. Take the salt solution in a beaker and immerse the uncovered ends of the 2 wires with the help of support. Switch on the current. Note whether the bulb glows. If bulb is glowing, it means that the solution of sodium chloride carries the charges of current, or the solution of sodium chloride allows the electric current to pass through it. It means that sodium chloride is a good electrolyte. Repeat the same procedure using the solution of 1 gram copper sulfate, 1 gram glucose, 5 ml dilute H2SO4 and 5 ml dilute NaOH, each in 50 ml water, and record your observation. The bulb glows only when electric current passes through the solution, and this can happen only when electric circuit is complete. In this activity, the circuit is found to be complete when the aqueous solution of NaCl, CuSO4, H2SO4 and NaOH are used. It means that the solution are the good conductors of electricity. Electrons conduct electricity through electrical wires, and ions conduct electricity through a liquid or a solution. Electrons leave the battery at the negative terminal and complete the electric circuit and enter the battery at the positive terminal. When there is a liquid or a solution in the circuit, 2 rods, wires or plates are immersed in it. These are called electrodes. Electrodes are usually made up of a conducting wire. Electrodes connected to the negative terminal of a battery by means of a connecting wire is called cathode. Electrodes connected to the positive terminal of a battery is called anode. Let's begin to study the concept of electrolysis. Take a solution of 1 gram copper sulfate in 50 ml water in a beaker. Use a thick plate of copper as anode and carbon rod as cathode. Arrange the apparatus as shown in the figure. Pass an electric current through the electric circuit for some time. In this activity, the copper appears to have deposited on the portion of the cathode immersed in the solution. When an electric current started flowing through the circuit, the cations Cu++ ion in the solution got attracted towards the cathode. Cu atoms are formed when electrons coming out from the cathode combine with Cu++ ion. A deposit of the copper appeared on the cathode. Cu++ ion in a solution were used in this way. The color of the solution remained same. While electric current was on, electrons were removed from the Cu atoms of the anode and sent to the battery through the electric wire. The Cu+ ions formed in this manner entered the solution. In this way, decomposition of the solid in the solution took place due to the electric current. This is called electrolysis. There are 2 parts in electrolysis process. These are the cathode reaction and the anode reaction. 2 parts of the electrolysis process that takes place in the above activity are shown here. If pure water is used in electrolytic cell, current does not flow even on putting on the switch. From this, we learn that pure water is a bad conductor of electricity, and we have already seen the reason behind this. The concentration of H plus and OH minus ions formed by dissociation of water is very low. The electrical conductivity of water increases on mixing a small amount of salt or strong acid or base in electrolysis of water. With the help of small activity, we are going to learn about the electrolysis of water. Dissolve 2 grams salt in 500 ml of pure water. Take 250 ml solution in a beaker. Connect two electrical wires to the positive and negative terminal of a power supply. Remove the insulating cladding from about 2 cm portion. These are the two electrodes. Fill 2 test tubes up to the brim with the prepared dilute salt solution. Invert them on the electrodes without allowing any air. Start the electric current under 6 volt battery. Did you see the gas bubbles forming near the electrodes in the test tube? Are these gases heavier or lighter than water? Are the volumes of the gases collected over the solution in the 2 test tubes the same or different? It is found that volume of the gas formed near the cathode is double that of the gas formed near the anode. Hydrogen gas is formed near the cathode and oxygen is formed near the anode. It is very clear that electrolysis of water has taken place and its constituent elements have been released. The concerned electrode reaction are as follows.